In question number 3 of our limiting reactant and theoretical yield series, we're asked, titanium metal can be obtained from its oxide according to the balanced chemical equation. When 28.6 kilograms of carbon reacts with 88.2 kilograms of titanium dioxide, 42.8 kilograms of titanium are produced. Determine the limiting reactant, the theoretical yield, and the percent yield. They're asking us to find 3 things here. We have to start with the limiting reactant. And what I want to do is write down all the information that they've given us right underneath the chemical formulas that they represent. So we're told that we have 28.6 kilograms of carbon. I want to convert that into grams because molar mass is recorded in grams per mole. So I'm going to take 28.6 kilograms and multiply it by 1,000. That's the conversion ratio. 1,000 grams per every 1 kilogram. Multiplying this by 1,000, I end up with a mass of 28,600 grams. I'll do the same thing for titanium dioxide, where if I multiply 88.2 by 1,000, I end up with 88,200. And finally, we're told that 42.8 kilograms of titanium are produced. So we have M is equal to 42,800 grams. The next thing that I have to do is find the molar mass of titanium dioxide and pure carbon. And I'll represent the molar mass by the capital letter M. And to find the molar mass, we need to find the molar mass of individual atoms of each of these chemicals. So starting with carbon, we have pure carbon, and it's simply 12.01 grams per mole. For titanium dioxide, TiO subscript 2, we have 1 titanium atom, so 47.86, plus the molar mass of oxygen times 2, 16 times 2. Using our calculator, we have 47.86 plus 16 times 2, and that gives us 79.86. And for convenience sake, I'll write these underneath. The reason why I found the molar mass of both of these is because with this, I can find out the number of moles, which I'll represent by the letter N. Finding the number of moles is important because that will help us determine the limiting reactant. And by knowing the limiting reactant, we can figure out the correct number of moles of titanium. So how do we go from mass and molar mass to moles? Well, what you do is you take your mass value and you multiply it by the flipped version of your molar mass. For example, if I want to find the number of moles of titanium, I'll take 88,200 grams and multiply it by 1 mole. Notice that 1 mole was at the bottom, now it's at the top, divided by 79.86. And by multiplying it this way, the amount of grams will cancel out, leaving us with only moles. So let's use our calculator. We have 88200 divided by 79.86, and this gives me 1,104. 1,104 moles. Keep in mind that your final answer should have 3 significant figures because all of the numbers that they gave us originally had 3 significant figures. We'll just have to remember that at the very end. Now, the number of moles of carbon. We'll do the exact same calculation. Take this and divide it by 12.01. 2,600 divided by 12.01, and this gives us 2,381. 2,381 moles. Now to find the limiting reactant, we have to compare these moles with the ratio that represents the number of moles of each molecule. Here's what I mean. We have 1 mole of titanium dioxide compared to 1 mole of titanium. The number of moles of TiO2 was 1104, and because it's a 1-to-1 ratio, Ti will also have the same number, 1,104 moles. Now let's do a comparison with carbon dioxide and titanium. This time we have a 2-to-1 ratio, and the number of moles here was 2,381. If we want to find x, we multiply 2,381 with 1 and x times 2. It's a simple algebraic statement. So 2,381 times 1 divided by 2 gives us 1,190. 1,190. Notice that this amount is smaller than 1,190. So titanium dioxide is our limiting reactant. This is our limiting reactant. And the number of moles of titanium is 1104. Next, we want to find the molar mass. The molar mass of titanium is right here. It's 47.86. 47.86 grams per mole. Notice that we didn't multiply it by anything because it's only one atom. Now to go from moles and molar mass over to mass, and remember what we're trying to accomplish here is the theoretical yield. We need to multiply these two numbers. So I'll take 1104, multiply that by 47.86, and this gives me 52,837 grams. Bringing this back to kilograms, I divide by 1,000, and this gives me a theoretical yield of 52.8 kilograms. 52.8 kilograms. And this is the theoretical yield. Lastly, they want us to find the percentage yield. So what we do is we take 42.8 and we divide it by 52.8. So 42.8 divided by 52.8, and whatever decimal number we get, we multiply by 100%. Let's go ahead and do that. 42.8 divided by 52.8 times 100, and we end up with 81.1. 81.1 percentage yield. And there you have it. That is how to solve a limiting reactant and theoretical yield question. Make sure to watch question 4 for our final example in this series.